People have so much doubts, I think, in this list.
My mic is off. What's up?
You might be have some lot of doubts, I think so.
Doubts.
Yeah.
धीरज भाई है, सब ठीक हो जाएगा.
Let's see.
So like
11. Let's make it 50.
so if anyone want to join, I can share the link, right?
Yeah. It's a public one.
Let me do it as well.
Okay. Now it's 7:10, so no need to wait for too
Sure.
much time. Okay. So everyone, hi, hello. This is actually the fourth meetup of Laravel Kerala, and hi, Remis, hi. And now today we have the Dheeraj here. He's the organizer of Laravel Delhi community, and he's good with the DevOps and all the Laravel things. Now we can go with Dheeraj and also joining Punibel here. So he's a very busy man with Twitter and LinkedIn. Okay, so Pundigal Shah, you can follow them on Twitter, so you can get him. And so now this is the community actually, Dheeraj, and the Kerala actually here. And now we can go for your session, and now your time. Okay.
Sure.
And before, yeah, 1 second. Before that, actually, so everyone, can you please enable the video so just I can take a screenshot and. So please, I'm requesting everyone to please enable the video. No one is able to. Yeah, Kishore is here. Fasana. Oh, Fasana is on bus or train.
Train actually. Yeah.
Okay.
You guys don't be shy. Just turn on your cameras.
This is fine. We don't need to spend more time for this. Okay. Okay. There is now you can start.
Sure.
Oh, wait. Robin is here. Robin too. Oh, okay. I took it. Okay. There is now you can start.
Okay, sure. Okay, so hello everyone. I'm really excited, and a big thank you to Jishad Bhai for inviting me over here. So I'm excited to talk to you all about scaling up the Laravel application, scaling up and scaling out both, and mostly out part because that's an infinite possibility. Before we start, there is something a little bit about me. Uh, I guess you guys can see my screen, right?
Yeah.
Yeah, perfect. So, who am I? I'm currently working as a DevOps engineer and software developer. I've been in last 5 years before. I'm a big traveler. Even I got introduced to Jishad Bhai while I was traveling to his hometown, Wayanad itself. I got his first call at that time. I enjoy taking photographs from phone. I enjoying paint. I enjoy painting, and I'm learning drum at the moment. And this is short about me. So let's get started. Let's see what we have. So first, before we dive into the topic, first let's understand what is scaling up and out. Like what is scaling up and scaling out. After that, we'll dive into the topic of Laravel. Let's take some example over here. So scaling up is basically you are having a machine and you can just increase the size of machine based on the service provider that you are having, AWS or Azure or GCP. They will have some upper limit for the machine. So there is a resource limitation. There is upper ceiling for your machine. You cannot scale beyond that. And also, just like this burger that you can see in the photo, so you can like stuff multiple patties in your burger, but after some time it will fail. Okay, so that will be a single point of failure. So if you just keep packing all your services and features into the single Laravel application, then it will definitely going to fail at some point. And also there is scale, and also there is a lots of load from the user, so it is going to have issues in the future. So this is scaling up. Uh, let's understand what is scaling out. Scaling out, instead of scaling up, this is scaling up vertically, will scale out horizontally. So there is a no limitation of the like size of the machine. You can start with a small machine, like very minimal machine that can be used for a very small application, like minimal usage application. Virtually there is no limit in case of scaling out. You can scale out infinitely, so you don't have to worry about the if you are having 1,000 customer or 1 million customer, so you can serve them based on your scaled out design. Or your scaled out application will be load balanced, so the 1 million customers request will be spread out to all your machines, and you don't have to worry about if one machine is getting crashed or one machine is going to be overwhelmed. Nothing will be like that. So uh, if you talk about the auto scaling and all, so basically whenever there is a more load, automatically your new machines will be deployed into the system, and your load will be balanced among all. And individual control. So basically, I'm not talking about microservice in this talk. I'm going to talk about the services in this talk. And different services you can scale up and scale down based on the different need. I'll take a small scenario. For example, there is a big billion day sale on Amazon. So on other days, people might not be using some services very much, but on some days some services will be used like really high in number. So for those days we can individually control those services. For example, the order services will be more on the big billion day uh, days, and for other days there might be search and cataloging service will be used much. So this is scaling out in brief. So how scaling out will look like. So this is how scaling out will look like. You will have infinite small burgers. You might have of different size, different taste, but yes, you can get as many as you want to, and you can also scale up and scale down whenever you don't want to. Like your if active user are down at the moment, you don't have to spend on the machines. You can always scale down. It's like that. Let's zoom in. Let's understand your Laravel application. So if you take a look into your Laravel application is going to be a burger that you can scale up definitely. So your Laravel application will have all the features packed into it, from database to notifications to caching, everything you have in your Laravel application. And all these are modules, and each modules talk to each other via internal APIs and kernels. They are highly coupled. You use single Laravel kernel as a core to run all those applications, all those modules and services. And also, your Laravel application can definitely be scaled up to some extent. For example, if you are a startup, you don't need to worry about the scale up and all. And once you grow, you can definitely grow your monolith app up to like 100,000 users or something like that. So based on the services and the request handling that you are doing on your Laravel application. So this is your typical Laravel application. If we just zoom into the Laravel application, what we'll find is uh, there are multiple components that I was talking about. There are database, there are session cache management, there are background jobs and queues that is running. You have file storage and file management. Okay, you have communication protocols, and you have authentication in Laravel application. That's a service based. This is very uh, uh, general component of the Laravel application, and this is going to be same for all other language application as well. I'm taking these because these are very common, and we are having uh, a wide variety of option to scale and deploy these services separately. So this is where we will use Laravel. This is where we will use different services and different approaches to scale out our application. So why we are going to scale out? So first, what our goal for the scaled out system is going to be, you will have multiple machines. So instead of big machine that we talked about, it's basically going to be smaller machines. Those will be doing some set of job, and after that you will be able to like scale up, scale down, add more machines to the services that I'll talk about. Okay. User request should be balanced. So if you have multiple machines, so you cannot just stuff all the user requests to one single machine. So it should be spread out to all the machines evenly, so that all the machines should have consistent resource usage. Data should be consistent. So what data means over here is, for example, you are using session for login. If your user request went to machine 1, user logged in, session got created over there, and in the second request, if machine request goes to machine 2, there is not any session. Okay, so user will be logged out on the second request. So in that case, we cannot keep our data on one machine or another machine. We have to think about some other solution, so that whatever data I'm putting for user 1 on one machine, it should be accessible for all the machines. So this is what I'll talk about as well for the session and cache as well. Seamless scale up and down. So once you have multiple machines, you cannot afford to keep all the machines up and running all the time, right? So those machines needs to be scaled up and scaled down based on the activity of the user. For example, if you are having a app that deals with the trading, share market trading, so you will want your number of machines to grow and number of machines to be high during the trade time. For example, 9 a.m. in the morning to 3 p.m. in the evening. And after that, you can reduce the number of machines in the evening time, and you can just do the regular maintenance work. Also, seamless deployment process. Now suppose you are having, say, just 5 machines. Okay, if you make a deploy auto deployment, so it should not just deploy on one machine, it should deploy on all the machines, and it should use some uh, approach to deploy, like blue green deployment. And like once machine is being deployed, it should get out of the load balance list, and then after deployment is successful, then it should go back to the service, things like that. So deployment should be seamless in your scaled up system. independent scaling. So I'll show you how your system look like. It's not like your Laravel application is using all the components 100% all the time. Some services or modules being used very high, some services being used very low. But if you have a single monolith application, so even if your small service needs to be scaled up, you have to scale up your entire machine, even if you don't need to. So that is not feasible in the monolith design, but in the design that I'll share, you can scale up each modules based on their usage. For example, database usage is high, then you can scale up the database component. If your cache usage is high, then you can scale up the cache component and things like file and all those components. There is next point called uptime. Even some machines fails. So I was talking about the single point of failure in the Big Burger example. In this example, if you have multiple machines horizontally scaled up, so even if your 5, 10, or 20 machine crashes, you will still be able to manage the user request. Your user request still be spread out to all the active machines which are healthy, and by the time those machines are being replaced with the healthier machines, your users might be experiencing some slow request, but your machine will your request or your services will not be down for those time as well. You just need to smartly plan all those, okay, and independently scaling if required. So that what I was talking about. I think this is repeated point. Okay. And also you have to keep in mind about the cost, flexibility, and control. So once you are talking about scaling infinitely, so you need to know that what's your cost ceiling is. So based on that, you have to plan if you want to scale out your machines, even if the load is 50%, or if you want to go to the 90% to launch new machines. So based on your cost calculation, you can decide the scaling part. And automation of moving parts. By moving parts, I am talking about the deployment, any changes in the machine configuration. You cannot do it in all the machines. Like you don't know at what time how many machines you will have. So make sure whenever the new machine is launched, you should have a configuration like that, like using Terraform or something, so that whenever new machine is launched, they will that new machine will have same configuration as all the other machines. So these things you have to keep in mind. So this is your typical Laravel application that it will look like. So your Laravel application is having some authentication, some modules for emailing and messaging. There will be some service worker and stuff, other services. There will be much used component like database. There will be even similar use component like file management or something like that, and there will be caching session, things like that in single application. And each modules is being used in a different ratio that I have just tried to represent over here by different size of the icons of the each services. So this is all about the scaling up your Laravel application. Let's talk about scaling out. So whatever component that I discussed previously, that we will take into the consideration, and then we will try to scale out. So first, we can use, let's start with the database, because this is going to be a very crucial part. So whenever application grows, that means this database and user and the catalogs, or say data grows basically. So in that case, you can't just keep growing your single machine. So first thing that you need to decouple is your database. Okay, from your like on the local development, you use the same database like localhost, but on the deployment, you use the RDS like services. Okay, so over here, we have just mentioned that we will use dedicated database service. This will offload the load of the database based calculation and process from your main machine. So this will create more room for your Laravel application to grow. Okay, even if you also need to plan. Sometimes your database request is not of all the same time. Sometimes you have less read and more write, and sometimes you have more read operations and less of write operations. For example, in Amazon, there will be less people uploading their products, and more people will be searching and purchasing their product. So the data of the product is more into the reading part, not into the writing part. So over here, we have an approach called a read replica. So what you can do is in Laravel, if you just search for the read connections in Laravel, so you will see there is a scenario where you can use a separate database just for the reading purpose. Okay, so Amazon RDS, for example, provide a read replica for your application. What it does is whenever a new write operation is done, it will be returned to the main master database, and after just writing, it will be replicated to another database as well, which you will use just for the reading purpose. So this way, if your read number of number of users grow which are reading your database, so you can just increase the number of read replicas all the time, and they will not affect your main master database. They will just keep a copy of your master database, and they will start serving from the read replicas. So this will going to drastically improve your Laravel application performance, even if the user is growing infinitely. You can just keep adding the read replica. Next point is multi-AZ deployment. AZ is for availability zone. So suppose your user is not in India, your user is in entire world, and you have single application that is being served to entire world. So this read replica cannot be just in India. You can put different read replicas in different zone of the world, in US, in Europe, in Africa, in India, in Asia, like any number of read replica you can deploy based on where your users are coming from. If you have like 60-70% user coming from the US, you will want to put 5-6 read replica in the US and few in other regions, things like that. So using multiple availability zone, you can scale your Laravel application to worldwide. Next point, let's see the cache and session. I was talking about the read application. So it goes to database, but you can still prevent user request from going to database by introducing the cache. So cache basically, if you just use the local cache, it will work for a single system. But if you are talking about the scale, so you can't put cache on one system, because either it will be have multiple copies, or it will not be able to update or invalidate whenever required. Okay, so what happens is, so you need to separate out cache from your machines. So all the machines will be able to read from the single cache, and you can grow your cache exponentially whenever you want to. So for example, you can use the Redis cache. Okay, also for this cache will be used for storing your frequently used data. Also you can use it for session. Okay, so this will decouple the session storage from each machine, and it will store on a single machine or single system, either in the Redis, or you can use the database for storing your session. So this way, no matter from which machine user is interacting, they will be able to have their login authenticated from all the machines, because it's stored somewhere else than on that particular machine. And again, whenever you need to, you can scale your cache cluster anytime, anywhere, and throughout the world. So you will just put the master URL of the Redis system, and it will internally use multiple cluster, multiple nodes, and it will serve you the cache. So the load of the database will further get reduced when you will smartly introduce cache in between. So this will be one of the prominent way where will help you in scaling of the system, scaling out the system. Okay. Next thing is background jobs. So in a typical Laravel system, we have lots of stuff that since we know that PHP is a single threaded language, And background jobs is very smartly divides your heavy processing task into the on separate thread. But again, it is going to consume some of the background processing on your machine. Uh, in case of multiple machines or say load balance multiple machines, you cannot run background jobs on one machine. Okay, otherwise it will be have either multiple copy or your jobs will be running multiple times, things like that. So for that reason, you can use SQS like services, or if you just don't want to go to the other services, you can just have a dedicated machine just to run the background jobs, nothing else. You don't need to configure the service worker on all the machines, only dedicate one machine for the background jobs and things like that. Okay, and if you use the services like SQS, so it will internally have lots of tools and lots of scalability. So you just need to plan what type of task you can offload from your main thread and push it to background jobs or things like that. So you will be able to reduce the load on the Laravel machines, and external services can take care of that. And you can also configure those background jobs frequency, the failures and everything separately as well from your Laravel application. Next we have is file storage. Your Laravel application might be storing some file images on your server, but since you are having multiple machines, so you don't need to store those files on your machines. You can offload all this storage functionality to some separate services. So you can use dedicated storage services like AWS is having S3. So advantage is that your machine is not going to store these files, and also those storage in the machine is quite costly. On S3 like services, it's quite cheap, and it can scale infinitely. While your machine is having limitation that it can store like number of files or size of the file until you decide the limit, 200 GB, 500 GB, or 5 terabyte, and you have to keep configuring. In case of S3, you don't need to set the upper limit. You will be able to store infinitely, and you just need to pay whatever amount you have stored. And also you can archive the unused data, and you can save the cost. So basically, for example, if you are having Facebook account from 2010, you are not going to access the post of 2010 or something, right? So Facebook might be smartly might be compressing your data and storing onto some other locations, because they have predicted that you are not going to use those data. So things like that you can also plan in your application. So you can plan like 20% of your data is active and people are going to use it. 80% of data, or even say last 20% of your data is not going to be used, or people are not going to have access to it. So you can archive it, and this will save into your cost. So this way you can uh, uh, increase the efficiency of the Laravel machines, and by using third-party services or basically decoupling from your Laravel machine, you can improve the performance of the Laravel app. So next is communication. I was talking about that Laravel is a single-threaded language, and mostly the communication part is handled by external APIs. Say if you might be using Mailchimp or might be using SCS or SendGrid. So those applications take time to process and get back to you, because it's a mostly web request. It requires network communication and things like that. So this in a single threaded language like PHP, this is going to be a bottleneck sometime. If you are having some application which require lots of communication, for example, you are having a e-commerce application and you want to send 5 notifications on making an order. So user might have to wait for the 5 notification to deliver before they get the success message. So you have to smartly manage those. You can definitely use the background jobs to send those notification communication in the background. And that background that background process will use the third-party APIs like SCS to send the emails. And also they have like third-party services like SNS. So there you can configure all type of communication, be it Slack, be it any webhook notification. You might be wanting to send your order update to order information to your say courier services so that they will come and pick the orders, things like that. So you don't need to manage all this in your Laravel application. You can decouple it and move to different services that you can go for. And also, you don't need to have a Laravel dashboard to manage all the channels, what kind of notification you want to have. Though Laravel have all this functionality built into it, okay, but you can definitely upload these stuff so that you can light up the Laravel application to do the business logic part of your main application instead of like making the external communication thing and things like that. With a minimal effort and with a combination of SQS and SNS, you can drastically improve the communication part of the Laravel application. So this is it. Next we have authentication. So Laravel is already having say Laravel passport earlier. Now Laravel is having lots of external APIs integrated to it, OAuth and all. You can use it, but also you can utilize the third-party authentication services like Amazon and Google provides. And based on that, what will happen is uh, user authentication, user storage, and things like that will be offloaded from the main Laravel. The authentication part, the failure part, the user is verified or not, things like that can be offloaded from the main Laravel application. And Laravel application will be just able to maintain the data part. Also, the permissions, you can use the multiple SDKs packages to manage the permissions, and you can offload this from the main Laravel application. You can have a separate machine just to do the authentication part, and it will be very rare to use service, and it doesn't need to be scaled out to all the like 100 machines if you have. And also, if you are having any critical services where you need to securely manage the data, you need to sometime have some certification that your data is secure. In those cases, you can use third-party services. Those third-party services will take care of the data storage, and the authentication and certification and compliances they can follow instead of you modifying your system to improve everything and do the things at your own. So also this part you can either do it in a hybrid way or just dedicate to the third party, which has like better certification, better trust for data security, things like that. So let's visualize what we have done after like discussing all this stuff, what kind of Laravel system that we have. So now this is your Laravel application is going to look like. Let me zoom into this and explain. I think let's zoom into over here. So this is your internet, and this is a load balancer that your infrastructure will have. In load balancer, you can also put some authentication in between before even going to main application. There could be some authentication mechanism. You can use API gateway for authentication or some other part. After that, you will have this is a set of your load balanced machine. This is called auto scaling group. You will have, I'm displaying 3 machines over here, but you can have infinite number of machines over here, and you can grow up and down this number of machines based on the load of the machine. For example, you are having 1 million active user at the moment, so you can request you can scale up your machine accordingly, and in the evening you might have only one say 100,000 or 50,000 active user, so you can scale down this machine to like support those only number of users that are active. So these all set of machines is going to have communication. So they will communicate to database. Okay. So over here you can see I have drawn a single database. This is called master database for the write purpose, and for read purpose they might have multiple read replicas. So all the read requests will be going to this number of read replicas, and only write operations will be hitting this main database. So this way, your database will be well managed. You can scale up this number of database, You can scale different modules into different database, and you can manage it separately instead of making any changes in the main application. Sometime you might have to change in the main applications logic. For example, there are some database where you just want to log the user's journey or user's request. So you can have separate database just to manage those, and all three machines can use that database specifically in the query part. In that case, you might have to update the query to use a specific database. So this way you can scale database independently. Okay, you have SQS services. Okay, so basically you can use background jobs and things like notifications and upload to it SQS services, and it will take care of the notifications and background jobs in the background. Your Laravel applications, at least a single machine don't need to worry it. You also, this can be replaced with a single machine where it will be just responsible for processing the background task. The notification part, you can also offload to some third-party services like SNS that I was talking about. Uh, Also for the read replicas, also for the cache, I'm sorry, you can use the dedicated cache service or a machine that will be just responsible to manage the cache. So all this set of machines will have the address of this cache services, Elastic Cache services or Redis Cache, whatever you want to use. You can use cache over here. And what flexibility you will have is, whenever you want to grow the size of cache, you don't need to worry about the machine. You can just grow up this cache part independently, and you can decide on the payment factor as well. If you further want to reduce the database call, you can grow up the cache, and it will improve your performance of the overall machine and your Laravel application. Again, this machine will also be talking to S3 bucket, where you all the file storage will be done. It might be your static files like CSS files or JavaScript file, or your images or your videos or any other heavy files, PDF and documents. You can totally decouple this from the single machine storage to one single storage of third party, and you can scale this up independently and infinitely. So this is going to be your new architecture for scaled out Laravel application. And uh, what interesting part is, each and every component is able to independently scale. So it is not advisable to use this sort of architecture when you just start your application, but in the later time, you have to, and you can choose this sort of application. This is not a microservice architecture. This is a just service architecture. So your single Laravel application that have multiple services inbuilt into it, I have just decoupled it and taken out of the Laravel, and then chose to use different services, so that your Laravel core will be supported by external services, and you will be able to grow your Laravel application. So this is your architecture part. So let's go to next part. So what you have now? So you have flexible scaling. As I mentioned, that each component you can scale independently. Number of machines you can decide. What is the size of database? You can decide. What is the number of read replicas? You can decide where is going to be read replica placed. You can decide based on the region where your user request is coming from. Cache size and flexibility you can decide. Session storage you can decide either on the database or either on the cache. Background jobs and the authentication or say notification, all those part you can flexibly decide. All your single application is now divided into the service. uh, each can have different machines or services, and like once I'm talking about the services, they are definitely working on separate machines, and you have flexibility to resize the machine. Costing, flexible costing. So you know that your if you just want some services to be blazing fast, you want to introduce more cache, so you can control, okay, I just need to increase the cache, and I will just spend the costing on the cache part. If I don't want to spend on the cache part, I might use database scaling up. So your cost is definitely uh, it's a negative point. One of the negative point is that you have to now manage cost of multiple stuff. But again, you have a flexibility and you have a detail that which part of the service is costing you more. For example, if your database call is making more cost, then you know that what part of Laravel you need to improve. Uh, you might be want to improve the database query, or you want to offload the query to the caching part, so that you can balance out the cost and you can improve your Laravel application. And also, in a single monolith application, you don't know what is performing good, what is performing bad. But in case of this service kind of architecture, so once the things come up at the cost level, then you are going to pay more attention to it, and you going to take those decisions seriously. For example, like microsecond level of delay might not be seems any making any difference in the small application, but once it grows, it might goes into the seconds. In that case, you know, okay, so I need to make changes in the database query on particular query, things like that. Business centric architecture. So if you see a typical Laravel application, it doesn't tell you about anything. But if you grow your application and grow into the multiple services, then you can decide your application will be looking like more like a your it will represent your business. For example, you are having a chat application, that then you might not have to use the database at all. So it won't be having database. So if everything is a real time, then you might not have to use the cache. So entire infrastructure is going to be business centric. Your cost and your spending and scaling, all the decisions will be your business centric. And also your Laravel application will have core business logic and incremental implementation plan. So this is very important. What I'm talking about, for example, let's go to this slide again. For example, I'm not asking you, or anybody is not going to force you, okay, just switch from monolith application to this part. Okay, so you can do it incremental way. For example, you can just separate out database from your main Laravel application at once. You can use it for 6 months or 1 year. If you feel load is furthermore, then you can spread out and introduce cache. You can take out all the file storage and use the S3 bucket. You can further, if you want, okay, I'm not able to scale up the EC2 machine of the Laravel, then you can plan up and go for the things like auto scaling and load balancer. Further, if you want to like offload further stuff, then you can use SQS, SNS, things like that. So this is not overnight change that you have to make. Not a single day you need to decide. You can have this change as incremental changes. So this is quite sustainable change. So I'm supposing if you are growing, then you're having a bit of revenues. So now you are able to spend a bit by bit on breaking up the Laravel main applications monolith into the small multiple services. So that will be easy for a business decision to take, and also in the long run you will have incremental investment, and you can plan for a scale like this. The conclusion part over here is uh, be modular. Always think, plan, and develop your applications, keeping that this part is going to be scaled in the future. Even if it is single API, so make it so independent that even if I need to take this API out of the Laravel, I need to have a separate machine, so it should be quite independent. Okay, so think like a modular, and in the early phase, it will be easier to scale up and scale out in the future. So at that time, you don't need to make the changes in the code. Okay, this service is communicating with another services very high level. We cannot just scale out. So at that time, you won't have to worry much if you just keep it clear and follow the principles like solid principle, things like that. So initially, what you see at the code level is going to be cost at infrastructure level later on. Keep looking out. So this is basically See, I mentioned all this stuff Laravel application is doing internally as well. Okay, so what I mean by keep looking out is keep looking out for the services that can help your applications to take the load off of the machines. So you need to be aware what kind of services are there. How can I use those services to reduce the load on the machines and improve my overall performance and things like that. So you have to be aware and you have to keep researching on that, and sometime you can just start testing, integrating, and if you find okay, this is making my life easier, then you can introduce fully and go for the final launch. Start small, develop for a scale. So this is first. This is the next part of the B modular. You can start small, but think for the future. You don't need to have. You don't need to like start a big plan, everything like RDS and all, and this at the start. But yeah, keep in mind that your application is going to grow in the future, and you have to prepare in advance by just making small amendments in your initial days of your application. So this is going to be pay a good amount of bills for you in the future. So this is all for now. So thank you. I would like to have some interactions with you to understand your if you have any doubt or questions. So I'll take that.
Okay, so thank you, Dheeraj. And if anyone want to ask any questions regarding the scale up and scale out things, just shoot it. I also have a doubt. I will ask in the last.
Sure.
If anyone have any doubts, please raise your hand. Okay, I think no one else have doubts. Okay. So let me ask you one question actually. This has happened on my last project. We implemented a project. So the scenario is actually is a bulk SMS marketing tool. Okay.
Okay.
So when we started the project and we just write the codes, the project will be handling some of the contact groups. There is a contact group, and inside the contact group there is a lot of contacts, something like that. So contact group have many relationships to contacts. Okay, so we will be sending a bulk message with to that numbers. That's a main feature of this project. Okay, so that time actually we just the sending form we will be just asking for the contact group ID and just collecting the message and just click on the button. The first time we on the controller we just process that just give a for loop and make something like that. Just insert this, push this job to individually. If its message is going to the 10,000 peoples, it will be pushed to the database job table like 10,000 jobs. Okay,
Okay.
something like that. Okay. Okay, so that time we just finished the development and just put to the server, and when the user is getting onboarded, and that time the system will be getting crashed, something like that. The first thing will be when a user is sending a 10,000 message like to 10,000 recipients, it is only processing around 60 or 50 jobs actually. The other ones will be not working, something like that. The jobs will not be getting coming to the database. So that's the first issue we faced. So then we look into the code and we understand that the memory can also only process up to 60 loops actually on a single processing time. So that's why we increase the server to like the first time it will be 2 GB RAM or whatever. So and some of the four which is CPU. We are actually using the DigitalOcean droplet actually. Okay,
Mm-hmm.
so that time we increased it till to something like 16 GB RAM to finish that actually. So
Okay.
uh, with the 16 GB RAM, we can loop all the for each loop actually for the contacts, and it will be pushing to the database. So that's it. Then we implement some of the other things like a scheduler will be processing that. We will be processing. We move the processing of the contacts to a scheduler, and scheduler will
Mhm.
not be break right. So we will be move that over there, and scheduler will be pushing to the database, and then we also chunk the contact group like with 50 or 60
Okay.
contacts,
In
and
batch.
it's then processed. Yeah.
Okay.
So it's like the batching. So after that, it is working perfectly right now. So this is the system we actually implemented. We just increased the server RAM to 16 GB, and if a user is getting coming with another 10,000, and right now it's actually sending with around like five campaigns a day. Okay, so in the future maybe there is 100 campaigns. It will not be enough actually the 16 GB. So
Okay.
what will you suggest that case actually? This is actually will be a common
Use case.
doubts actually for the yeah.
Okay. Okay. So let me reiterate what you said. So if I'm wrong, you can let me know. So you wanted, you had a system to send from the background jobs, but at the time of adding to the background jobs, you are failing, right?
Yeah, but it's actually we fixed with the scheduler. But the question is actually if we need more users, I mean more campaigns are getting day by day. So
Hmm.
we are improving, I mean upgrading the server to high end. So that's so is there any other
Scale up
way,
part.
or we can yeah
Yeah.
other way or
So, did you use scheduler itself to add to the queue? Because what I
yeah.
think is okay. So that I think is going to solve your problem because say you are saying the number of okay. So what you can do is you can increase the number of background jobs processing machine. So
Yeah.
there is a machine
So
that you are having
we
which is
actually
process. Mhm.
yeah, we actually in the starting stage actually we will be the concurrent operations will be two or something, and then we
Mhm.
increase the RAM, and the concurrent operations are like it's will be changed to 10 or 15 something like that. So the
Okay.
speed is actually improved, like 10,000 messages will be gone in a 1 minute of that's
Mhm.
fraction of times actually.
Okay.
So that's we
So
did actually.
okay, so your data, what you can do is you can initially have a separate machine just to process the background jobs.
Mhm.
Okay, so that will take the load from your main machine, and the background jobs machine you can add horizontally. You don't need to have one big machine. You can have like two, three small machines, and you can add and remove the machines whenever you want dynamically. So that will be your solution for the like infinite solution. And only take care things that you need to take care is of database. Is your all the machines going able to handle and process the data at once from the database? So you just need to have the read replica that I was talking about. So your write application is write database is not going to be burden when lots of jobs being processed. Only your read replica is going to be involved in that time. So all the other user will be I think it's a in-house application, or there is not lots of user, but the background processing is more. So in that case, yes, you can use the some set of machines, say 4 or 5 machines, and you can delete and remove the machines when you don't have lots of background jobs running, so that you can provision dynamically.
Okay.
Yeah. So one machine can 1 or 2 machines you can use quickly to add the jobs. All the jobs will be added, and then will be some number of the machines. You like you can have a single machine configured to run, say maximum. For example, you have 2 GB machine, and say suppose it can process 10 concurrent requests or 15 concurrent requests. And if you think the concurrent request needs to upgrade, instead of upgrading from the single machine, you can just make a second copy of that machine. Okay, so it will
Okay.
going to be doubled when things are done. So you can just turn off the machine, and you can do that dynamically based on the load of the
Okay.
machine. Yeah.
Great.
Yeah.
So anyone else actually Punipal? Very
Nipal, I
useful.
was expecting a lot from you.
Yeah, me also.
No, I don't have any questions.
Okay.
Okay.
I can ask one question. Mm,
Okay.
What are your thoughts on using Laravel Octane while scaling?
Lara Lockton.
Yeah,
Right.
with Roadrunner or Franken PHP or any kind of.
I'm sorry, I'm not aware of that at the moment.
Okay.
Frank and PHP, you were talking. I was having some discussions, but yeah, I didn't went into the details
So,
at that
like,
time.
yeah, I'm not talking about Franken PHP. I'm generally talking about the Laravel Octane.
Okay, so no, I haven't tried with that at
Okay.
the moment. Yeah.
So it is like it keeps your server up, right, for
Okay.
every request
Okay.
coming to the server. So if we are using fast CGR kind of stuff,
Mm-hmm.
uh, every time new request come, it loads and boots the whole application, right?
Okay.
But
Okay. I, I guess I have some idea. So
yeah,
kernel is not getting involved invoked all the time, right?
yeah,
It is put in the into the memory and only
yeah,
okay, I got it. Yeah, I think that is a good approach, but again it will have some ceiling as well. So after
right,
some time, like there is not you can definitely take this as your first approach when you are growing. Okay, if you don't want to go, okay, I'm having enough budget for the 8 GB machine, I can use this solution for next like 2 3 iteration, and after that you will definitely is have to think of the futuristic solution, especially when you don't know when user is going to be flood in and user is going to flood out again. So in
yeah,
that case, you can't think it and do it manually. You have to plan something so that it all goes automatically. Uh, Automatically scale up your system, automatically scale down your system, and save the cost. So yeah, your
okay,
approach is this approach is going definitely going to improve the overall performance. For example, if you might have used if you need say 10 machines, it might be doing work in a 5 machines if you implement
Mhm.
this solution all over. So yeah,
Okay.
this is good solution. Yeah.
Thank you.
Okay. Thank you, Jishat. Thank you,
Okay.
everyone.
Anyone else?
Anyone else?
Hello. Yeah, Shabir.
Yeah, Sabir.
Shabir, tell me.
Hi all,
Shabir.
Hi,
a great
Sabir.
presentation.
Thank you.
Uh, I was just looking like how well we can handle these architecture using Vapor, Laravel Vapor.
Laravel Vapor. Okay. So
Yeah,
Laravel Vapor, I guess it's doing serverless, right? Right.
Yeah.
right, right.
Yeah.
Yeah. So again, there are some limitations on the serverless part as well. Again, there will be lots of use case application to application. Any application which is able to see the first challenge that is going to be molding your application into the serverless part. Okay. And for that you need to really break down your system into the smallest services, and I just broke into the services, and then you have to break into the microservices. Vapor is good solution, but yes, you might have to make good changes in your applications, and also the management of the lambda based application is a bit tough. I'm not much aware about the nitty gritty detail of the Vapor, but yes, the once you put things into the serverless part, the function based deployments, and then you have to take care of lots of stuff. Laravel Vapor might be a good solutions up to some extent, but yes, there will be some use case and limitations all over it.
So you suggest is like we do it uh, manually using like AWS or
See, initially
cloud
again,
solution.
yes. So in what you can do, you will have full control of your own. Okay. Even if
Okay.
you use the Laravel Vapor, you might have to pay for the Laravel Vapor and all the infrastructure that is going to be in that handling. With using AWS or GCP or Azure, whatever solutions that I have provided, it's you can deploy, and they have similar services in all the clouds, and you can control individually. Okay, you don't need to make the drastic change in your application to make it serverless, and things will be basically Laravel. So you won't have to think about, okay, now your application is totally changed. Whatever I have mentioned, Laravel have inbuilt capability to connect all the services like that. So I've not broken Laravel into very smaller unidentifiable services. You still have main Laravel working, and you have all the APIs of Laravel that is communicating with all these services. So in further future, like if you like, there will be further limitations on the Laravel. In that case, people can, what you can do is you can like move individual APIs into different languages, right? If you think, okay, this part of Laravel is quite tough, PHP or Laravel is not going to handle this, so I'll write this particular API in the Go language, Golang, and then you can use the API gateway to call that particular API from the different server which has Golang. So things like that. So there will be always incremental way, or you can either plan in drastic way initially. That will have some cost of development on your part as well.
Okay.
Thank you.
And there is one more doubt actually from my side. Okay.
Sure.
So actually, see, we create a Laravel application, and suppose we can say that a REST API is calling in from the job. Okay, so that's my
Okay.
the jobs will be handled there. Okay,
Okay.
so when I control resubmitting, the jobs will be going to the jobs table and it's processing. So my concurrent running operations will be one that I configured on the forge like one. Okay, so if
Okay.
where I have hundreds of users is there, and
Mm-hmm.
hundreds of users are pushing the data to the jobs.
Mm-hmm.
That the last one will be getting delayed with this. All the jobs need to be processed, and we need to be like in the queue. It will be happening, right? So,
Right.
is there any way to reduce the time performance with that only without upgrading the server? What is the I mean better way?
Okay. So you are saying that your background jobs is calling one of the Laravel API, right?
Yeah.
Okay, so there are two way. One way is you can like directly call machine, like one of the machine or things like that, like providing API hardcode URL, or you can just use the external like main application URL of the Laravel. So in that case, what will happen is your application, no matter how many number of requests is there, your load is going to be balanced among the all the machines. Even if the machines like CPU percentage got increased and resource is being used a lot, and request is getting slowed, then your load balancer is going to like your auto scaling system will going to launch new machines, so that your request will be processed in parallel. And I think the bottleneck that you're talking about, if you have hundreds of users and hundreds of users have hundreds of jobs running, or they have put the request, and then those jobs is going to be calling same load balancer, and then internally they will either use the number of machines that you have in parallel, or they can launch the load balancer can auto scaling group can launch new machines to keep your request healthy.
Okay, so it's only the way we can only like upgrading the server. That's the only way I think, right?
So you can definitely go for the internal improvement, but that is quite subjective. Which part you are handling, how you are handling. So if you think that okay, your request is not going to take much of the time, then there won't be launch of new machines. Your existing set of machines is going to handle all those. But if your request is taking much time, your resources piling up, CPU usage is going up, RAM is being used up, then you have a condition in the load balancer auto scaling group. If the CPU usage goes beyond 70%, launch new machines. Okay, so
Okay.
only in that case, auto scaling group will be triggered.
Okay.
I have something in the chat. Core PHP or Laravel is better for beginner. Ah, so it's just like which is better, Bootstrap or CSS? So Laravel is good to start, but again, you have to sometime you have to come back to the like core. Okay, how things work internally is always a good idea. So you should be able to understand how things work internally, If you don't know how, like if you don't know CSS, then you will stuck at Bootstrap somewhere, okay, and you don't know what to
Exactly.
do. You don't have solution in Bootstrap. So yes, Laravel you can start, but definitely you should be having as much as detail about the core PHP, how things work internally, how you can modify the Laravel applications or packages when you have to for your particular use case.
I
Yeah,
think Punipal has something to say about this.
yeah, it's like use Laravel, but when it is time for performing, then use some PHP stuff in between Laravel. It's
Yes,
like use Eloquent every time, but the queries which is
taking
like
much time. Yeah,
taking much time, use a DB like facade directly.
directly. Yes. Yeah, because if you like keep using Eloquent, you don't know how SQL look like. So if you anyone
Yeah.
who started PHP core PHP, they have good SQL knowledge. But if you just started Laravel, you don't know what SQL is, how internally things work. So you should be able to like, okay, Laravel is not going to handle my Eloquent. I can go to the facade. I can write raw query, and that will be most performant part of your application in that case.
Yeah,
Yes.
but it is not like required every time, right?
Yeah, it will not be
Yeah.
required every time. Again, if you want to keep your Laravel intact, either like you have two options: either go to the deep, write facade, or you can scale up the server and just keep the code as it is, beautiful code, if, whatever your preference is.
Remember what Goose said, start with the server which have just 2% capability, 2 years
Exactly,
capability.
exactly. I remember that. Yes,
Yeah.
and then you can scale up and break everything apart, and then you can add in performance. Everything.
So it is like people say, don't think about the problem which doesn't exist.
Exactly.
Yeah.
So start
Exactly.
small. Yes. Perfect. Okay. Welcome,
Okay.
Mohammed.
So
Anyone else other than?
yeah, like how much Docker's involvement in the scaling? Like how much it is involved?
Yeah,
So
that's it.
I mentioned we have broken the Laravel into the small services. Okay. Over at this point, till this point, you won't need Docker. Docker is needed when you can definitely go like package entire Laravel application and go to the Docker. And Docker will again, if you use Docker and Kubernetes, Docker will make multiple copies of your machines. Again, you have to take care of all this stuff. For example, okay, let me share my screen so that I can explain better. So what will happen is, let's see. Okay, so what Docker will do is, Docker will a second. Docker will just make a multiple copies of this, but you don't want to have multiple database, multiple cache on all the machines. Okay, so if you can dockerize your application, first you need to improve your application. So best part is like the best solution would be create a Docker image of this part. Okay, so all this part can be external, and Docker image or say Docker container will be able to like communicate with all these external service as the same way. Basically, what I was talking about I was talking about the services. Now it is going to be microservices. So even if you use the entire Laravel application and you want to use the Docker, you can definitely go, but we have to follow this architecture in that case. So your application is going to have single database communication, single caching, single source and destination where they can read and write the files. You don't want your container to have all these inconsistent data everywhere. Okay, and you also want this to be very small. So yeah, Docker is a solution. Docker is definitely going to be solution, and later on, once you further break your application into the microservices, then yeah, it is further going to scale up. So first level, you can use the Docker, but again, you have to think of this infrastructure. I have specifically mentioned this in the terms of AWS and load balancer auto scaling group. but think it like a Docker and Kubernetes cluster, and this is going to be same. So this there is going to be master Kubernetes, and this is going to be your Kubernetes cluster, which is having multiple Docker container, and all these containers going to talk to the single database or external services in the same way. So yeah, architecture is going to be same, and you just need to plan internally how things will work. So once you are comfortable with this, either go for the Docker or go for the inbuilt AWS architecture. So this is going to be look the same.
So it is like everything is distributed in different services, right?
See, think yes. So whatever can be decoupled from the Laravel main application, we can decouple in this scenario.
It's like few
And what
jobs and all.
exactly? So whatever is common is going to be same in all the machines. So in that case, you can use this approach. So this
Okay.
is all going to do the same work, and this is going to be
Yeah.
consistently separated.
Okay. So actually, that wasn't my actual question because
Okay.
I asked that question because like we can uh, get one stage where I can
Mm-hmm.
ask this question. So it is
Okay.
like if we have everything distributed in different services, right? So
Mm-hmm.
what kind of things we have to like do take care of while deploying new version of the app?
Okay. So whenever you want to deploy the new version of application, so make sure your each machine have all the dependency installed, existing machines, and make sure whenever the new machine is going to be launched, it will have the same configuration of the machine. So that whenever new machine is launched, if you have new package or new extension installed into your machine or new Apache configuration, then new machine should have that as well. So you need to have a blueprint ready, that we say the template image in the auto scaling group, and you have to modify auto scaling group template all the time whenever you want to make changes into this machine part. The code part will get automatically updated. Whatever the deployment command is, git pull, composer install, things like that, you can configure into the command, and it will deploy in all the machines. But whenever you want to make the changes into the actual machine configuration of the machine, you have to update the image, and you have to update in all the machines, push using the third party tools like Ansible or things like that. Or you can just like update few machines, delete other machines, and then launch new machines, things like that. You can do this way.
So, so how much downtime it can like generate? Like how much downtime we can get?
So you can decide based on that. Say for example, in the 4 to 5 in the morning, you will have least traffic. Basically, uh, you want to have like least affected user. Okay, so basically in the in the daytime, all three machines is being used. In the 4 and 5 a.m., only one machine is going to be used, and this will be enough to serve all the user. So what you will do is, while you are updating this machine, you can take this machine out of the like this active group. Okay, and you can deploy on all the other machines, or just update this machine, put this machine back into the system, and then take out this machine. So you know that okay, this machine going to take care of the load that we currently have, and you can just delete this machine. That will totally work. If you just delete this machine, what will happen is, whenever user load will increase, it will launch new machine with the same this configuration. Okay, so you just need to like say, if you want, like, okay, if you know that at 4 a.m. minimum 3 servers is required. Okay, in that case, you have to update in all these minimum servers. Okay, whatever the minimum server that you need to basically it is called blue green deployment. So you can take some machine offline, update those. Okay, bring it offline online, and divert the user data to the new machines. Like once you put the in the active group, your user request will be sent to those machines, and the other machines you can just take out from the active group. So they will take care of that. So you can deploy all those machines, and new machines, I guess you have to first update the template, so that whenever new machine is going to be launched, you that will have same Apache configuration or the hardcore configuration that machine needs to have.
Okay, thanks.
Okay.
Okay. Anyone else?
Okay, I was having one more question actually.
Go ahead.
Today.
So it's like we were having like a single writing database and multiple reading database, right?
Right,
That
right,
scenario, right?
right.
So it's
Definitely.
like how we handle the updates, right? When like someone is updating, right? We have multiple reading database. So do
Mm-hmm.
we need to log that particular data or what we do?
So basically, RDS take care, like services like RDS take care of that. There will be some like minor delay in the service. There might be some minor delay in the service, but whenever you update the master database, it instantly update all the particular database. Or what you can do is, to be more sure, you can like, if you want, there is some critical data that needs to be right, so you can like use a database connection with a read string, so you can update the read database from your end as well. So if you just what I'll do is, I'll take out a search and I'll do read connection Laravel. Okay, so if you just okay, so there is a good article over here. I guess you guys can see my screen. So for example, you can have multiple connections to read and write, and if you want to specifically write the read database, you can also select that. So you can run your query and update part on your database itself. If you don't like want to take any risk that, okay, I don't want to wait for AWS to update, you can directly update the read database as well. So this way you can do that.
Nice.
Any more questions?
No.
No.
Okay, perfect. Uh, okay, so should we wrap up?
Yeah,
Okay, perfect.
that's right. And thank you all to join on this meetup actually. And thank you, Dheeraj, for taking this kind of great session. And thank you, Puneval, to join on the meetup actually. Okay. So we'll meet on the next meetup. And thank you, everyone.
Thank you, everyone. It was
Thank you, then.
nice
Bye bye.
meeting
See
and
you.
talking to you all. Thank you. Bye.
Thank you. Bye.
Thank you. Thank you all.